Welcome to our mini lesson on stem and leaf plots. A stem and leaf plot basically is a way to visually show the distribution of data while we still have the value of the numbers. So let's go ahead and take a look at what a stem and leaf plot is. This is a stem and leaf plot. What this represents over here is the tens column. So this would be 4 in the tens column, and then this is the ones column. So 4 in the tens column and 1 in the ones column. This would be 41. This would be 42, 43, 45. Same with down here. This key shows us that 5-2 means 52. So 5 would be the tens column. And all these numbers are separate individual numbers inside the ones column. Again, it's kind of a visual representation. So if we look at this quickly, we'll see, well, it's pretty even among the 50s, 60s, and 70s, but there's a couple more inside of the 40s. All right, so it kind of gives us a visual image. And if we had a really long list of 50s that would come out to here and the other ones were lower or higher, we'd be able to see kind of quickly what area has the most number of numbers. All right, so in this case, this is the tens column, this is the ones column. So if we picked a number randomly like this here, that 6 represents 5 in the ones column, or in the tens column, 6 in the ones column, so that would be the number 56 right there. Okay? Let's go ahead and make a stem and leaf plot. What we have here is a list of numbers that we have made into a stem and leaf plot. All right, you see inside our list of numbers, they're not all in order, but we have 12, 14, 16, 25, 23, 27, 15, 36, 48, 25. And we've taken all of these numbers and put them into a stem and leaf plot. So each number that has a 1 in the tens column, like 12, 14, 16, and then another 15 is up here, all of those will be under the 1 in the tens column. So here's the ones column of 2, so that would be 12. This is 14, 15, and 16. All of those numbers are in this list. And the same with the numbers that have 2 in the tens column. In other words, they're in the 20s. So we have 23, 25, 25, and 27. I wanted to list 25 twice just to show you that if there are 2 of the same number, we do list them twice. Okay, so 23, 25, 25, and 27. And then there's a 36 and a 48 also in this list. So here's a quick stem and leaf creation that we've made just to show how we can take this list and order it in a way that's a little bit more visual for us. Another way that we can divide up the stem and leaf and kind of show it in a visual way is called quartiles. You know, like percentiles. Well, this is a quartile, or in other words, we're dividing the data into fourths or quarters. So the first thing we do is we divide it in half. So we find the middle number. The middle number is also known as the median. Okay, so we find the median first, then we find the middle of the lower numbers, or in other words, the median of the lower numbers, not including the middle median. And this is called the first quartile, or Q1. Then to find the third quartile, we would find the middle of all of the greater valued numbers. Again, not including the middle number. Let's go ahead and show an example of this, of dividing into quartiles, and I think it'll make a little bit more sense. So find Q1 and Q3. Step 1 is that we'll find the median, or the middle number. To do that, we're going to count. Just like we did when finding the median in a regular number, only for us it's all nicely ordered here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 total numbers, so the median will be number 6. 1, 2, 3, 4, 5, and 6 right there. That'll be our median, the number that's right physically in the middle of this list. Now, when we have it organized in a stem and leaf plot, we can see that that is it has 5 on one side and 5 on the other side. 3. All of those ones are less than this, 25, and all of these ones are greater. So our next step will help us to find the first Q1. It is the number in the middle of the lower numbers. So all of these numbers are less than the median, 12, 14, 15, 16, and 23. The number in the middle of those is called Q1, or the first quartile. So let's go ahead and take a look at that. There's 1, 2, 3, 4, 5 numbers. So the middle of those is this number right here, 15. That's going to be Q1. And we do the same to find Q3. We look at all the numbers that are greater than the median. So 1, 2, 3, 4, and 5. There's 5 above that median, so we would pick the third number above, in other words, 32 right there. So to kind of lay it out this way, the median would be 25, Q1 is 15, and Q3 would be equal to 32. And you can sort of see, it's not always going to be in a line like this, but you can see that when the median's chosen, you can physically see that it's in the middle, and then this one here you can again see that you're dividing the lower numbers in half, and this way you can see that you're dividing the upper numbers in half. So again, the stem and leaf plot is a visual aid to help us see these numbers being divided up into quarters. So that is our mini lesson on stem and leaf plot. It's just a tool that's used to display numbers visually. I hope that this lesson's been helpful for you. Have a wonderful day.
Welcome to a lesson on histograms. A histogram is a bar graph that represents a frequency distribution, as we see here below. The width represents the interval, and the height represents the corresponding frequency. Notice there are no spaces between the bars. So looking at the given histogram, notice how the intervals have the same width or the same size, which once again means the bars have the same width. These categories here, or the intervals, are often called the bins. And then notice the vertical axis indicates the frequency, so we can easily see that the mode of wait times is 4 to 5 minutes. Looks like it occurred 13 times. Now let's construct our own histogram. Here we're given data on average gas mileage of 20 cars. So before we create the histogram, we'll complete this frequency table where we already set up the intervals. Once again, notice how they have the same width or the same size, and there are 7 intervals here. We can say we have 7 bins. So we'll first go through and tally the data in the correct interval and then find the frequency. So starting with 24, which would be in this interval, then we have 17, 14, 22, 25 and 26, both in this interval, 38, 42, 24, 12, 28, 19, 32, 21, 35, 28, 21, 31, 18, and 19. And therefore the frequencies will be 2, 4, 5, 4, 2, 2, and 1. So we'll use these intervals or these bins along the horizontal axis, and we'll use the frequencies along the vertical axis. Let's go ahead and set this up. Starting with the intervals of the bins, we'll divide the horizontal axis into 7 equal intervals. So 1, 2, 3, 4, 5, 6, and 7. So let's go ahead and label them. The highest frequency is 5. Let's go ahead and have a maximum value here of 6. Break this into 6 equal pieces. And now we'll construct a bar for each bin or each interval. So for the interval from 10 to 14, the frequency is 2. To make a bar with a height of 2. The interval from 15 to 19 has a frequency of 4, so we make a bar with a height of 4 over this interval. The next interval has a frequency of 5, so we make a bar of height 5. The next frequency is 4. The next two frequencies are 2. And the last frequency is 1. And here's our histogram. And once again we can see that the mode would be the interval from 20 to 24 for this data of average gas mileage in miles per gallon. I went ahead and created the same histogram using some software with the same results. This histogram was made with Excel. There is one more thing I'd like to mention before we go. If there are no breaks in the data, then normally the last data value of a bin is the first value in the next bin. For example, looking at the given histogram on heights of black cherry trees, notice how the horizontal axis is labeled by 5s, so this first interval or first bin looks like it goes from 60 to 65, and the second bin or second interval goes from 65 to 70. So the question becomes, where is the 65? Is it in the first bin or is it in the second bin? And it's actually in the second bin. This first interval is from 60 to 65, where if we use interval notation, it would be closed on 60, meaning it includes 60, but it would be open on 65, meaning it does not include 65. The next interval would be closed on 65 and open on 70. The value of 70 would be in this third interval. The third interval would be closed on 70, meaning it includes 70, but open on 75, meaning it does not include 75, and so on. So it is important to keep this in mind if you see a histogram labeled as we do here. I hope you found this helpful.